Hey there, so next video is going to involve surface area of pyramids and cones. So recall that surface area refers to the total area of the object's faces, but what makes pyramids and cones different is that it's not rectangles that surround our bases now. There's only one base, and what surrounds it are triangles. So we have a new formula here. We still have to take the area of the base, and to account for what's surrounding that base, which are now triangles, we're going to take the perimeter of the base times not the height, but L, which represents the slant height. This is going to be new, and this is going to be challenging, but we do not want the height here, because the height does not help me, okay? What's going to help me is that in this triangle, the height of that triangle is called the slant height, okay? So that is going to be a new thing. We do not want the height. We want cursive L. We want the slant height. So in this figure, the base for this pyramid is a square. Okay? The area of that square is 20 times 20, which is going to give me 400. The perimeter of that square is 4 times 20, which is 80. The slant height is given to me as 30, which is helpful. So now I can just plug it in to my formula. Surface area is going to be one area of the base, because there's only one base, plus the perimeter of the base times the slant height divided by 2. Because those figures that surround the base are triangles, so base times height divided by 2, perimeter of the base times the slant height divided by 2. Okay, so I'm going to plug that into my calculator, and we get that the surface area is going to be 1,600 millimeters squared. Okay, so it's very nice when all that we need is given to us. Let's now go to our next problem, which may make us do a little bit more work. Base, once again, is a square when we're dealing with this type of pyramid. The area of the base, well, we know this part's 45, which means I need to double that in order to get a side length of 90. So area of the base is 90 squared. So that's going to give me 8,100. Perimeter of the base is 4 times 90, which is going to give me 360. Now, we don't know the slant height. What we're going to be needing to do in these problems is set up that triangle where the height is 97, the base is 45, and the hypotenuse represents my slant height. I hope you can see that triangle in here. Height over to the midpoint of the side, and then the height of that triangle is actually the slant height, which is the hypotenuse. So when we do Pythagorean theorem there, this is going to be the square root of 97 squared plus 45 squared, which is going to give me, and I don't need to simplify this, but I do want to keep it exact. I don't want to round until the very end. So the slant height is going to be the square root of 11,434. So to finish this out, surface area formula is equal to the area of the base plus the perimeter of the base times the slant height all over 2. So when I plug that into my calculator, and I don't want to round until the very end, I'm going to get 27,347.379 centimeters squared. Okay? So that is how you do a problem like that if you don't have the slant height. You're going to need to use some Pythagorean theorem in order to figure out that. Okay? Let's go on then to a cone. In a cone, the base is a circle. So if I draw that circle separately, the area of that base, pi r squared, so that is going to be 9 pi. Perimeter or circumference is 2 pi r, so that is going to give me 6 pi. Slant height, we don't know. So we're going to set that triangle up separately. And my slant height, after doing Pythagorean theorem, is going to be 5. So now we can just plug it into the surface area formula. Surface area is equal to area of the base plus perimeter of the base times the slant height divided by 2. So surface area, our exact form is 24 pi meters squared. Our approximate form is going to be 75.398 meters squared. Okay, so again, we had to do a little bit of work there in order to figure out the slant height since it wasn't given to us. So now find the radius of a cone with a surface area of 40 pi feet squared. So we're given the surface area. We're also given the slant height as 6 feet. Okay, so maybe we can draw a diagram to help us out here. But we don't necessarily need that. Okay, we're trying to find the radius. Well, we need the radius in order to find both the area of the base and the perimeter of the base. To find the area of the base, that's pi r squared. To find the perimeter of the base, that's 2 pi r. So if I set up what I know within my area formula, surface area formula, it's going to be surface area, which is 40 pi, equals area of the base, which is pi r squared, plus perimeter of the base, which is 2 pi r, times the slant height, which is 6, divided by 2. After simplifying this, I'm going to get 40 pi equals pi r squared plus 6 pi r. What I'm going to do now is divide everything by pi. And when I do that, the pi's are going to go away and leave me with 40 equals r squared plus 6r. Well, this is a quadratic, so I need to get this set equal to 0. R squared plus 6r minus 40 equals 0. Factor this. It's going to factor to r plus 10 times r minus 4 equals 0, which means r is going to be 4 or r is going to be negative 10. Well, a radius cannot be negative, so the radius is going to have to be 4 feet. Okay, so that's how you can work backwards on one of those problems. Let's wrap up by finding the surface area of a hexagonal pyramid. So we want to find surface area. Base is a hexagon. If I draw that hexagon separately, has an apothem of 5.2, and it has a side length of 6. So area of the base is apothem times perimeter divided by 2. So that's going to be 5.2 times perimeter of the base. That's going to be 36 divided by 2. So area of the base is 93.6. Slant height is fortunately given to us, so we don't have to do any more work there. So now we can just plug it into our formula. Surface area is equal to area of the base plus the perimeter of the base times the slant height divided by 2. And when we solve that, we are going to get the surface area to be 297 miles squared. So that is going to wrap up this video. If you have any questions, let me know. Other than that, you can continue working on your problem set and have a good one.